Welcome to section 2.5, Inverse Trigonometric Functions and Triangle Problems. At the end of this section, you should be able to answer these questions. What is an inverse trig function? What information does it supply? Why do the inverse trig functions have restricted domains? What are the domains of the inverse trig functions? The inverse sine, the inverse cosine, and the inverse tangent of the angle. What is a principal branch? How are the domains of the inverse trig functions determined? And how can inverse trig functions help us solve right triangle problems? Well, let's look at what an inverse trig function is. In a trigonometric function, we input an angle and our answer or output is a ratio. With an inverse trig function, we input a ratio and our output would be an angle because we switch our input and output information in any inverse function. So for instance, if I had an angle that I took the cosine and ended up with a ratio of 0.8, 8 over 10, 4 over 5, I could draw the cosine function as I've done here and draw a line at 0.8, and we see that there are multiple angles that give a ratio of 0.8. So what we need to do is narrow down our possible answers so that our inverse relationship for the cosine no longer violates the horizontal line test. We're going to select a region of the cosine graph that covers all possible outputs or ratios, but does not repeat. We'll define that area of the graph to be the principal branch of the cosine, resulting in a function for the inverse cosine. For that relationship to occur, we need to pick an area of the graph that is 1 to 1, strictly increasing or strictly decreasing. I've highlighted on this graph the area of the cosine that is typically chosen to represent the inverse cosine graph. Those values go from 0 to 180 degrees. We follow a similar process for each of the other inverse trig functions. We need to find an area of the graph on the sine curve that is strictly increasing or decreasing and covers the entire range of possible ratios from -1 to 1. So what we have chosen is the region that is closest to the origin and is strictly increasing. So our possible angles that are covered go from -90 degrees to 90 degrees. We've already discussed the cosine graph. We decided to take the positive angles closest to the origin on the strictly decreasing portion of the graph from 0 to 180 degrees. The tangent graph has an interesting graph. We'll discuss its behavior in the next chapter. But as we can see, it's also periodic, so we need to pick a strictly increasing or strictly decreasing region of the graph that covers the entire range, which happens to be all real numbers. Again, we're going to pick one close to the origin to keep our numbers convenient. So we're going to take this branch of the tangent graph to be our principal branch between -90 and 90 degrees.